Alright, Year 12. If you're watching this video, I'm obviously away. So here we go. So we're into our second Year 12 topic, which is networks. And today we're looking at drawing networks. Feel free to fast forward this when you're watching it. So it's drawing a network. First thing you need to know, the difference between a connected graph and one that's not connected. Connected graphs, where you can travel from each vertex to all the other vertices. For example, here I can go from A to B, A to C, A to D. I can get to each of those vertices, okay, in this graph. Same with this one here. To get from A to B, I can get there. I just have to go via C, but I can still get there. These are connected graphs. Same with that. Ones that aren't connected, you can't travel from each vertex to all the other vertices. So, obviously in this one, you can't get to B. Okay, there's no line out there to B. Or in this graph, right, you cannot get from one side to the other side. There's no connecting edge. All right. So, we're going to draw some. So, if we take this map of Australia and draw the connections between the capital cities, step one is to draw and label the vertices. Okay, and I've given you that on the guided notes. Then I would suggest that you start at one vertex and connect to all the relevant vertices and keep going. You don't have to use straight lines, but if you use them, it makes them easier to read. So if we look at, this is on your notes, so we've got Australia, here are all the vertices labelled. Okay, I'm going to start in Perth, and I noticed Perth, from Perth, squiggly line though, I can get to Darwin. So Perth to Darwin. I can also go from Perth, squiggly line without going through Darwin, all the way to Brisbane. And I can go from Perth to Adelaide. Now, although I can get in my car and I can drive from Perth via Adelaide and get to Melbourne, I can't go there directly, so I'm not putting a direct line to Melbourne. All right, now I'm going up to Darwin. From Darwin, it looks like I can go over to Brisbane without going, to Adelaide without going through a capital city, and to Brisbane. Okay, again, I can go from Darwin to Canberra, but I'd have to go through Brisbane, or I'd have to go through Adelaide or Melbourne. All right, so I'm not joining that. So I'll move around to Brisbane, I think. No, I'm moving down to Adelaide. From Adelaide, I can go to Brisbane, I can go to Sydney, I can go to Canberra, and I can go to Melbourne directly without going through another city. Moving to Melbourne, I can go to Brisbane, Sydney, and Canberra. Move to Canberra. So I went to Brisbane. I can go to Brisbane, and I can go to Sydney, and then if I move to Sydney, I can go up to Brisbane. So I think I've connected everything. Obviously, we can't go to poor old Hobart via a car and be in trouble. So if you looked at it, I started at Perth, and I just went round the vertices, okay, until I covered every vertex. Okay, so if we look at isomorphic graphs, they're the same one, the same graph, they're just drawn differently. So this is the same as this, and you can check it out by looking at the connections. So A goes to D, A can go to D directly. A goes to C, A goes to C directly. B goes to D, B goes to D directly. B goes to C, B goes to C directly. And then D goes to C, D goes to C. So they have the same connections, they're just drawn differently. And neither one is better than the other. Okay. If we look at non-isomorphic graphs, okay, this looks very similar, but it's not quite the same. There's a connection A to D, there's a connection A to D. But in this one, there's a connection A to B. There is no connection A to B. Okay, you'd have to go through another vertex. So these are not the same. The textbook example says, which of the following graphs is not isomorphic to the other three graphs? So what I do is I start at a vertex, and I'm going to start at C. And here I can see C joins to B and D. And here, B and D. Here, B and D. Okay. If I go to this one here, it does connect to B and D, but it also connects to E. So that graph there is not the same as the other three. Now, if I was being very thorough, I would check all the other vertices. So to check if graphs are isomorphic, check each vertex and see where each edge goes to. Okay. All right, now we're going to be drawing a network diagram. So this is another example out of the textbook. Here's the network in a table form, and it's about students who work together to solve problems. Okay, so Darcy worked with Bo, Alyssa worked with Bo, Alyssa worked with Claire, Darcy worked with Claire. Question A says, what will the vertices of the diagram be? It's going to be the students' names. Okay. B says, what will an edge actually represent in the diagram? An edge is going to represent students who have worked together to solve a problem. Okay. C, draw the diagram. So I'm going to start with my vertices. So I've got Darcy, Bo, Alyssa, and Claire. Now you can put them wherever you want, in any order. Okay, I just went with that order. And now I'm going to connect. Darcy worked with Bo. Connection. Darcy also worked with Claire. Connection. Alyssa worked with Bo. Connect. And Alyssa worked with Claire. So I've created a network diagram. Okay. Now it's not the only one, because D says draw an isomorphic graph of the same diagram. So I did that. All I did was change. See how it's a crossover? I changed a couple of vertices. Okay, so I put Alyssa where Claire was, Claire where Alyssa was. It's the same network, just looks different. Which student, from that question E, which students have not been able to solve a problem together? Obviously, Claire and Bo, there's no connection, and Darcy and Alyssa, there's no connection. All right, so that's drawing just a network from a small table. The next question says, here's the network, put it in the table. Okay. So the first thing I'm going to do is, it's these, where these things cross, right, we're going to put the weighted edge in here. A to A. There is no A to A. A is just A. So the first thing I'm going to do is I'm going to go down the center of this table and fill it up with, no, it doesn't exist. Okay. Then I'm going to look at the network diagram. A to B is 9. Whatever 9 is, it's in there. A does not go directly to C, so I'm putting a dash. A does go to D. A does not go to E. Okay, and I'm going to keep filling it up. I'm going to go round to the vertices. So B to A we've already done. That's 9. B does not go to B. That would be silly. B goes to C. 3. B does not go to D, but it does go to E. 4 units. Okay. Then I'm going to go to C. C doesn't go to A. C goes to B. 3 units. C to C is just C. C does go to D, but it doesn't go to E. Okay, so I'm filling this up. I'm going to D and then I'd go to E. So I've completed a table from the diagram. It's just being thorough. It's nothing difficult, just being careful. All right, now we're going to take a table and we're going to draw the diagram. I'm going to start at A. Okay, so A, again, it's got A to A, there's nothing. But A to B is 32. So joined it up and I've weighted my edge 32. A to C, 15. A to D is 20. So I've connected anything that A connects to, according to this table, I've connected it up on my graph. So I move to vertex B. B to A is already done. B to C, 30. B to F is 18. Moving to C. C to A is done. C to B is done. C to D is 10. I better add that. C to E is 53. And C to G is 24. Now I'm changing colours just so it's easier for you to see what I'm doing. There is no need to do that. Moving on to D. D to A is done. D to C is done. D to E, put it on, going down to E, and finished them off. Okay, so I'm just very slowly going from vertex to vertex, completing it up and adding my weights. Okay, I think that's the last slide in this presentation. So it's your turn to go and do the exercises.